Hi class, today we're going to be discussing molecular compounds. These are nonmetals that share electrons in order to fulfill an octet. So this is chapter 6.5. Molecular and covalent mean the same thing. Covalent, molecular, nonmetals that have valence electrons that will move around to share, they will move in order to share the electrons within each other, so that each element has either an octet or in some cases with hydrogen a duet, which is 2. A molecule is a discrete group of atoms in definite proportion. So a molecule is non-atoms that come together that share electrons to create a compound. H2O, we know that as water. That is a molecule. Water, regardless of where it's found on Earth, it will always have 2 hydrogens and an oxygen. H2O, that's what it means of a discrete group of atoms in definite proportions. Carbon dioxide is right here. Carbon dioxide has a carbon and 2 oxygens. It will always have this. Carbon monoxide has a carbon and an oxygen. And what you don't see here, we draw these so they look a little cleaner, because if I draw nothing but dots, this does not look as nice. So if we count all these, they all have octets, 2, 4. So if you jump over here, 2 electrons equals 1 dash. So that's why we draw them as lines, because they look cleaner. 1 line equals 2 electrons. So 2, 4, 6, 8. This oxygen has an octet. 2, 4, 6, 8. This carbon has an octet. 2, 4, 6, 8. This oxygen also has an octet. Now, these are double bonds. We'll get into those later on in another section. This is a triple bond. Some molecules can handle more than 2 electrons within it, amongst it, like this. So this one has an octet. 2, 4, 6, 8. This carbon has 8 electrons around it. 2, 4, 6, 8. This oxygen also has 8 valence electrons around it. So this is what they do. When I say they will move in packs of 2, and they will move over in order to allow this compound to exist by these elements sharing electrons within them. Now, we're going to first discuss the naming of these before we go into anything more. This naming is very different than ionic compounds, and you need to make sure you are you understand the difference between naming these, because if you name them wrong, they're wrong. And a lot of students don't understand that. They cross over, and you cannot cross them over. This is very similar to addition and subtraction rules with multiplication division. You will try to use rules on one, and it won't make sense when you look at the answer. It's because you're not following the correct rules. You have to follow the rules that go with that. So this is where we're going to introduce prefixes. These are going to be in front of the element name. So unlike with ionics, we didn't talk in the name about how many chlorides were with magnesium, and there would be 2 of them. We would just say magnesium chloride. With nonmetals, covalent molecules, we do. We use this naming in front to tell you exactly how many exist, and we do not reduce down. So there's a difference. So the first nonmetal, if you have 2 elements together, the first nonmetal is the element name. So that does not change. It's the same as with the ionic compounds. Second nonmetal is named with "ide." So we also change the "ide" here as we did with the nonmetal that's with the ionic compound. Now the difference comes that we are going to discuss the subscripts, those little numbers that are at the bottom. I didn't have it out here, but this is CO2. So the 2, we will bring in the fact that there are 2 oxygens to this. And that's how you'll know just by the name of it. So the standard kind of formula is a prefix, first element, prefix, second element, and then the "ide" ending. So if we look over here, we have carbon, and as a rule, we generally do not use mono in front of an element that's by itself. So it's kind of like when we don't use a 1. So this is carbon, and the di means 2, if you look here. So this is dioxide. Carbon monoxide, mono means 1. And that's where the namings come from. So again, mono is not used in prefix in the front. So if it's mono, we tend to just say the first element name, and we do not use mono in front. Okay, so here is again, I'm bringing in these names that we saw on the first slide. So this is carbon dioxide, not monocarbon dioxide. This is carbon monoxide, not monocarbon monoxide. The number, this is, I'm specifically bringing this up because this is one that confuses students. And if you go online, you will actually see variations of this. So not everybody follows the rules again. Just because things look really official online when it comes to chemistry, if you don't know the rules, you tend to follow what they're saying. But if you know the rules, you know they're not doing it correctly. So here is the terms that we add to the compounds. But what if something like mono gets added to something like oxide? That's two vowels together, like right here. Nitrogen monoxide. We don't use that. One of these gets dropped. When the vowels of O and O or A and O appear together, the first vowel is omitted. So what it means is that we would drop the vowels that are with the prefixes. So the A would go away and the O would stay if it's oxide. So it'd be heptoxide, not heptaoxide. And these are some of the things, if you do a search online, you will see that they still carry this and they don't drop it, and that's not right. So this NO is not nitrogen monoxide. It is nitrogen monoxide. Oh, and I just put it here. I accidentally messed it up here. So it's going to look like this. I tried to fix it and I ended up making it worse. So it would be spelled like this, where you can see the one O and not two. Okay, so here's some common molecular compounds that you may not really think about, but you've all heard. Carbon dioxide, nitrogen oxide, maybe you've heard sulfur dioxide, but these are all used in commercial uses that we see here listed. Okay, so let's get started practicing naming these. So the first thing we have is a nitrogen, and it's 1. So this would normally be mono, but again, we don't use mono. And then we have 3 chlorines, and that's 3. So let's look at tri. So this is going to be tri. So the first step in this is that we're going to determine what the first element is, and that's nitrogen. Now we name the first element by its name, and we do nothing. If this had more than 1 nitrogen, then we would add a prefix, but it doesn't. So we're just going to leave that as nitrogen. The second element, also a nonmetal, is chlorine. But remember, we changed the ene to ide, so it's chloride. And then the third one, we add prefixes where they need to be. So in this case, there's 3. So that's going to be tri. So the name of this is nitrogen trichloride. And again, we do not use mono in the first element. So this is nitrogen trichloride. All right, so here's another one. We have B2O3. So let's take a look what the 2 is. The 2 is di, and the 3 is tri. By the way, I didn't mention this, but you definitely need to learn these. If you do not learn these, you will struggle and pretty much fail this section. You have to learn them. They are not difficult to learn, and they make your life easier, and they save you time if you know them. This doesn't go away. This is naming, and in chemistry, we just keep building upon this. So memorize these, flashcards them, do what you need to make sure that you know these just right offhand. So there's this di, and this is tri. So next thing we need to know is what the first element is, and this is boron. So boron has 2 of them, but we're not going to worry about the subscripts till the end. So we have boron. Second one is oxygen, and we change that to oxide. So we have boron oxide. We have the skeleton of it, but we need to actually add the subscripts. So we know that the 2 is di, and we know that the 3 is tri. So now we fill those prefixes in. Diboron trioxide. Again, an I and an O, this is okay. These can be next to each other. That's not a big deal. So diboron trioxide. And now this is asking for the molecular formula. So we have the name, we want the formula. So let's take a look at what this is. This is di, before we even look at anything else. Di means 2. Pent, it would be penta, but we dropped the A on this. And it is 5. So 2 and 5. So the first thing, now that we have discovered what the subscripts are, we need to also now determine what the element is. P is for phosphorus. and O is for oxygen. So now we can bring those down because this is asking for the molecular formula. Another thing students get confused on, understand what's being asked of you. Don't just learn the content, look at what the instructions are stating and determine what that means. Molecular formula. Ingrain it in your mind that when it's asking for molecular formula, that means the actual elements that are on the periodic table with the subscripts. I can't tell you how many times students will ask me, well, I don't know what this question means. I can only tell you to a certain extent. I will never give you the answer. And part of learning this is learning how to decipher what's being asked. If you're doing the problems, make sure you understand the instructions without just jumping in because visually you can see what needs to be done. You're failing if you're not also learning the definitions that go with that part of whatever that assignment is. Because then when it comes up and it's used in different terminology and there's nothing but a blank page, now you're stuck and you don't know what's being asked. So this is molecular formula. You'll be given the wording, so you need to get the formula for it. So here is the P, we bring it down. The 5, we bring it down. We know that this one has 2, this one has 5, and there's P2O5. And that is diphosphorus pentoxide. Okay, so this is where students have a problem understanding how to use naming. Naming, it's very simple, but it also is overwhelming for students who this is not something you've done before. 2 things you need to remember, and those 2 things will always help you understand how to name something. If it is ionic, ionic has a metal and a non-metal. So if it's ionic, you're taking something from this side as the first element and something from this side as the second element. So look at a periodic table. If you get confused on how to name something, look where it is, the first element is located. If it's located in the metal portion, you are naming that following ionic rules. If it's covalent, everything's over here. Both first element and second element are over in this section. Then you will use the prefixes with your naming. So here is nitrogen and oxygen. This compound is covalent, meaning it is a nonmetal and they are going to share electrons. This is dinitrogen oxide. Now this is the weird thing. In some rules with some oxides, we don't use mono in front. I don't think I'm going to avoid trying to give you things that have some weird exceptions to them, except for carbon dioxide and carbon monoxide, because those are pretty known. But if you were to write monoxide on this, I would probably give this to you because there are some weird exceptions and it's really hard to get some of them understood. So this is, to me, this is what the slides gave me. I think this is a poor example. I would have found something else. But dinitrogen oxide, dinitrogen monoxide, I would give it just because, yeah. Now the ionic compound has potassium, and now there's a 2, but we don't use dipotassium. Why? Because it's a metal. You cannot use prefixes on metals. So this is not dipotassium. This is potassium oxide. So again, location tells you everything you need to know. If you have the first element here and the second element here, you use ionic compound naming. If you have first element here, second element here, then you use covalent, which has prefixes. Here's the naming chart. So molecular, first metal, non-metal, use a prefix. Second non-metal, use a prefix and an "ide." And then ionics have here how to tell you which was which. All right, so let's do some practice. This is silicon. This is actually a metalloid. This is silicon, and then we have Cl4. Metalloids we do use the prefixes for. So on here, we have a 4. 4 is tetra. So silicon being by itself, there's not going to be anything in front of it. That's a key to help you understand this. Nothing in front, but we can look for the tetrachloride. So this is silicon chloride. That's wrong because it's not telling you there's 4 here. This is naming it like it's an ionic. This is tetrasilicon. That's wrong because it's saying there's 4 silicons and 1 chloride. And this is silicon tetrachloride. 1 silicon, 4 chlorides. This one we just did, but let's break it down again. This is phosphorus and oxygen. We have 2 phosphorus, so that we're looking for a wording that begins with di. And we're looking for an ending that begins with pento, because we're going to drop the A. So this is diphosphorus pentoxide. So phosphorus here, no, because there's not 1. And this is not counting the 5. Phosphorus again, no, because there's not 1. But the pentoxide is correct. Diphosphorus pentoxide. So this is going to be C. Now we have, again, 2 nonmetals. We have 2 chlorines and 7 oxygen. So the first thing you're going to look for is di, because there's 2. Dichlorine. We name it chlorine. Chloride is only for the endings that we change the "ide" ending. First elements stay exactly how they are on the periodic table. So dichlorine, and 7 is hept. So heptoxide, I mean. So this is dichlorine. Here's a dichlorine. This is heptoxide. The A is dropped, so it's going to be A. But let's take a look at why these would not work. Dichlorine is correct. Oxide is not. It's not telling you there's 7. Chlorine here is not correct because it's saying there's only 1. And heptoxide is correct. So this one also is not telling you the amount for the first element. And there's the answers for these. Okay, so now let's test if we understand what is ionic and what is covalent. That determines the different naming systems for these compounds. So location, location, location will tell you if you look at a periodic table. So S is here and O is here. This is covalent. So this is going to be a covalent compound. And the correct name, so because it's a covalent, we have to involve the prefixes for it. But let's take a look at those after. Second one, barium is here. Chloride is over here. This is an ionic compound. Barium's a metal. So different naming is going to happen with this one. This one here is a polyatomic ion. It is the only one that is positive, so it goes first. Positives always go first. And this is also a polyatomic ion. So this is an ionic compound. You'll name it with the ionic compound rules. Copper is here. It's a metal. So once you determine the first part, you don't even need to worry about the second. This is an ionic compound. We'll name it correctly with ionic compound naming. Nitrogen is here. Oxygen is here. This is a nonmetal, so this is going to have covalent bonding to it. So let's take a look at the names so we can break them down. First one is covalent. Yes, it is. So we have sulfur. First element has nothing to it. It's just 1, so we're fine. 3 to the oxygen, so that is trioxide. Sulfur trioxide. Ionic. Ionics do not use prefixes. So this is straightforward name only. So barium chloride. Here is another ionic. We do not discuss prefixes. So this is ammonium phosphite. Phosphite because there's only 3 and not 4. And now we have this is a Roman numeral. This is how we're going to say it. Remember, we use crisscrossing. This one is interesting because there are 2 oxidation states for copper. There's copper 2 and copper 1. So this one, if we crisscross it down, we notice there's nothing in parentheses around this. So that tells me this is 1. There's a 1 here. The 2 that was with the charge of the carbonate's been brought down and it's not reduced down. So this is copper 1. Copper 1 carbonate. And here is covalent. So we use prefixes with this. So this is 2 is di, 4 is tetra, but we drop the O, the A that comes with the tetra. So this is dinitrogen tetroxide. And that's it. Thank you.